Welcome to today's video, where we'll take a comprehensive look into the world of circuit analysis. Whether you're an aspiring electrical engineer, a hobbyist, or simply curious about how electronic devices work, understanding circuit analysis is crucial. In this video, we'll delve deep into the fundamental concepts, tools, and techniques that form the backbone of circuit analysis. So, let's embark on this journey of discovery. 1. Definition and purpose. At its core, circuit analysis is the systematic study of electrical circuits aimed at understanding their behavior and properties. It involves analyzing and predicting the voltages, currents, and power flowing through different elements of a circuit. By unraveling the intricacies of circuit analysis, we gain the ability to design, troubleshoot, and optimize circuits, enabling us to harness the power of electricity in a controlled and meaningful way. 2. Basic elements of a circuit. A circuit comprises various elements, including voltage sources, such as batteries or power supplies, resistors, capacitors, inductors, and other components. These elements are interconnected through conductive pathways, forming closed loops for the flow of electricity. Understanding the characteristics and behavior of these elements is fundamental to circuit analysis. 3. Key concepts and techniques. A. Kirchhoff's laws. Kirchhoff's laws are fundamental principles that underpin circuit analysis. The first law, Kirchhoff's current law, KCL, states that the sum of currents entering a node must equal the sum of currents leaving the node. This law ensures the conservation of charge in a circuit. The second law, Kirchhoff's voltage law, KVL, states that the sum of voltages around any closed loop in a circuit must be zero. KVL is a manifestation of the conservation of energy. B. Ohm's law. Ohm's law, named after the German physicist George Simon Ohm, is a cornerstone of circuit analysis. It defines the relationship between voltage, V, current, I, and resistance, R, in a circuit. Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it and inversely proportional to its resistance, I equals V/R. This law allows us to quantify the behavior of resistive elements in a circuit. C. Circuit analysis techniques. Node voltage analysis. Node voltage analysis is a powerful method that employs Kirchhoff's current law to determine the voltage at each node in a circuit relative to a chosen reference node. By assigning variables to the node voltages and setting up equations based on KCL, we can solve for the unknown voltages and understand the distribution of voltage in the circuit. Mesh current analysis. Mesh current analysis involves applying Kirchhoff's voltage law to calculate the current flowing through each mesh or loop in a circuit. By assigning variables to the mesh currents and setting up equations based on KVL, we can solve for the unknown currents and comprehend the current flow within the circuit. Superposition. The superposition principle is a technique used when multiple sources, such as voltage or current sources, are present in a circuit. It states that the response of a linear circuit with multiple sources can be determined by analyzing the effects of each source individually and then combining them algebraically. Superposition simplifies complex circuit analysis by breaking it down into manageable steps. 4. Tools for circuit analysis. Multimeter. A multimeter is an indispensable tool for circuit analysis. It is capable of measuring voltage, current, and resistance in a circuit. By using different modes and probes, a multimeter allows us to verify component values, troubleshoot faults, and validate circuit performance. It is a versatile device that assists us throughout the circuit analysis process. Circuit simulation software. Computer-aided circuit simulation software, such as SPICE, simulation program with integrated circuit emphasis, has revolutionized circuit analysis. These tools enable engineers and hobbyists to analyze circuits virtually. By inputting circuit schematics, component values, and desired analyses, simulation software provides accurate predictions of circuit behavior. It aids in circuit design, optimization, and rapid prototyping. 5. Applications of circuit analysis. Circuit analysis serves as the bedrock for numerous applications in the field of electrical engineering. Electronics circuit analysis is crucial for designing and analyzing electronic circuits, such as amplifiers, filters, oscillators, and digital logic circuits. Power systems, understanding and optimizing the flow of electrical power in grids, power distribution networks, and renewable energy systems relies on circuit analysis principles. Control systems, analyzing and designing circuits for feedback control in automation, robotics, and industrial processes depends on circuit analysis techniques. Telecommunications, circuit analysis plays a vital role in studying and optimizing circuits for communication systems, such as signal processing, transmission, and networking. Conclusion: circuit analysis is a captivating field that unlocks the potential of electrical circuits. By grasping the concepts, tools, and techniques we've covered today, you are equipped to navigate the intricacies of circuit analysis. Remember, it takes practice and exploration to become proficient. So go forth, unleash your creativity, and embark on exciting circuit analysis adventures. Thank you for joining us today, and we look forward to seeing you in the next video.